Good afternoon, everybody. My name is Mark Orr, and I'm the Executive Director of the UK and Ireland Spill Association. And I'd like to welcome you to this knowledge base webinar on aerial surveillance and drones. It's an area which I'm really passionate about. It's really one which I think is beginning to really grow, and people are beginning to understand the potential of it. Now, I'd like to firstly say our thanks to OAMPS Hazardous Industries. They are our association event sponsors, and so the money that they help enables us to put on events and to put on webinars like this. So I'm very grateful to them. As I said, the aerial surveillance and drones, it's really, really cool. And this is perhaps the cooler end of some of these knowledge-based webinars. And the reason we started these knowledge-based webinars really was to share our members' world-leading knowledge and enable it to be found, accessed, and shared. And as a result, enabling the knowledge which is shared in these to sit there on our website so they can be used as a toolbox talk, or over time can just be a place where those who are involved or interested in spill response can come to inquire, increase their knowledge, understand what good looks like so that they can work more safely, be compliant with the relevant legislation, and really deliver a better service. But also, feel free to delve into our knowledge base, because there's lots of good stuff there spoken by professionals with a lot of experience, and they're great toolbox talks. They make great stuff for guys who are coming into the industry to learn from, and also to see the scope that this industry now covers. And in a sense, the webinar we're doing today is at the sort of sexy end of spill response, in that it's helping to find it, it's helping to find where spills are, and it's I think it's going to be a very, very growing part, a significant growth area in our industry. So it's really good. So far we've done about 14, I think we've done 14 knowledge-based webinars so far this year. We've had a break over the summer, and it's really great to be back. So, we also have articles which be relevant to our knowledge base in Spill Alert. Spill Alert is free, it's easy to access through our website, and I'd recommend you go on there. If you go onto our website, it's ukeirespill.org/publications, and you'll Spill Alert, see Spill Alert down there. Also, you'll get all through the knowledge base, you'll get all these webinars, plus other webinars that we've done and other pieces of useful information. And also we've got our LinkedIn page, which is well followed, and we post stuff on there of interest probably several times a week. Now we're starting our autumn series, if you like, through till Christmas, and we've got four webinars programmed as part of knowledge base. This one, aerial surveillance and drones, will be followed by drill rigs and selections, spill response to biofuels in November, and soil sampling and analysis in early December. And then we will be doing one on marine plastic pollution, what is currently being done by whom, and I think this is a really very pertinent area at the moment. And we will be wrapping up the Wakashio story. We were intending to do this to show the stern section of this vessel off the reef, which it grounded on over a year ago. Unfortunately, the stern section is still there, but as soon as it's off, we'll get a picture of the reef from our friends at PolyEco, and we'll then be able to conclude this sad episode. The other thing I would ask anybody who's on this webinar, if there's something you want us to follow, or want us to cover, just send it through, and we'll do our best to piece together a knowledge-based webinar or a pertinent webinar on the things which interest you, because we enjoy doing them, and if we can share a bit of knowledge, I think that's great. So today we've got two great speakers. Juan Peña-Ibanez is one of the founders of Orbital EOS. Orbital EOS is a company I came in touch with because I was seeing lots of their very, very dramatic and really cool images on LinkedIn. Phoned them up, or we had a discussion on Zoom, And I was really motivated to follow them and see what they're doing. Now, all of the founders have come out of the Spanish Maritime Coast Guard, and they've been dealing in the area of maritime spill response and maritime protection for the Spanish government for many, many years. And Orbital EOS is a spin-out company from the Spanish Coast Guard. They're all very, very experienced. And as people who've been involved in that, they understand what the user requires when they get information, which is why I would say they've got cool images, which are relatively easy to interpret. So Juan's going to kick it off, and he's then going to hand over to Richard Stark. Richard was introduced to me by one of our board members, Mark Shepherd from NRC, based up in Scotland. And Mark is talking with Richard about them providing a drone support service to NRC for both their offshore maintenance work, but also their inland management of oil and gas resources. And so Richard does a lot of work offshore in his company, but they also do work on inland infrastructure. And of course, if you are a large oil company with a lot of risk, one of the things you need to do is to patrol it and survey it. And with drones becoming more cost effective, but also more capable, drone surveillance is one of these options. So really, this session is all about aerial surveillance and drones. And I think, you know, we will get two great presentations. Now, the way we'll handle questions, if we could, is please put them in chat, and I'll manage those questions at the end to both of our speakers. So I think that's enough from me. So I'll hand over to Juan, and let's go. So I'll stop sharing, and Juan, off you go.
Okay. Thank you very much, Mark, for the introduction. I will now share my screen. Okay, so hopefully you're seeing the first slide of my presentation,
yes,
right?
Great.
Okay. So good afternoon, everyone. Delighted to be here. My name is Juan Peña, and I am the CEO of Orbital EOS. EOS stands for Earth Observation Solutions. So we basically use satellite imagery and advanced analytics to provide services. And in this case, I would like to highlight that the company itself is specialized in satellite-based oil spill monitoring. So I would try to demystify what is this of observing from space and how satellites can help us in this oil spill management. So the title of my presentation is Using Satellite-Based Intelligence in Oil Spill Monitoring. Okay, just, let me start in the beginning of the story, because as I shared, I'm from Spain, and Spain experienced its major environmental disaster in recent history in 2002, as you know very, very well, after the accident of oil tanker Prestige that sank carrying 77,000 tons of heavy fuel oil. It has been catalogued by some sources as the third most expensive accident in history. Several years later, the Spanish government acquired 3 maritime surveillance aircraft, 3 units. The name of the aircraft is CN-235, equipped with remote sensing systems in order to detect and characterize oil spills at sea. I had the chance to be involved in this operation since the very beginning, working as a tactical coordination officer on board the aircraft. And what we had to do basically was to gather information using the sensors on board the aircraft and to detect and characterize oil spills, identify the source, and produce reports for the maritime authorities. So just to describe you a little bit of how this works, normally this kind of aircraft has what we call a side-looking airborne radar, which is the sensor that is designed to be a primary detection tool for oil spills at sea. It's an X-band looking airborne radar, and Normally, it has a swath, it covers an area below the aircraft of around 30 kilometers. So we can patrol the ocean and detect potential oil spills and then investigate further. We also had a full sensor suite of other equipment, not really designed for detection, but for characterization of the oil. So we had a forward-looking infrared that helped us to identify oil spills during the night as well. It had night vision capacity, infrared and ultraviolet line scanner in order to describe the thickness of the oil. Microwave radiometer, also a sensor designed to detect thick oil patches, and a laser fluorescent light that is a very fancy tool to classify oil spills, so we can know whether it is really hydrocarbon or not. So during the period 2007 to 2017 that I was involved in this operation, we detected, investigated, and reported more than 1,000 spills at sea in the European Exclusive Economic Zone, including 2 major accidents, one in the Canary Islands after the sinking of the Oleg Naidenov Russian ship that sank at about 4,000 meters, a very, very challenging situation. So my thoughts on this are that definitely an aircraft is a fantastic tool for this. But it has also some constraints, some drawbacks. The first one is that we have a limited reaching coverage because, I mean, we cannot fly 24 hours a day. We have fuel limitations. The endurance is limited. And we must not forget also that there's a crew on board that has to eat, has to sleep, and has to rest. So our, let's say, surveillance capacity is big, but it's limited. There is another drawback, that is that, the operation of one of these aircraft implies a high operational cost. Just purchasing one of these aircraft could cost an authority around 30 million, and operating it on a daily basis or on a regular basis could cost around €1 million per year. So it's a significant cost that we have, of course, to consider. And the third one are safety implications related with having an aerial asset at sea. Normally, you have to fly. You have to fly over the sea at low altitude, and very, very often at night, because, as you know quite well, some ships tend to pollute deliberately at night, so the likelihood of being caught is lower. So during that period, we had many night patrols. Another aspect that I would like to highlight, and it's quite significant in the context that we're living right now, is that operating an aircraft like this implies producing 95 tons of CO2 that go to the atmosphere. And now I think it's very, very relevant to have this into our notebook. So the Spanish Coast Guard, as many other European Coast Guards and maritime authorities in Europe, is an user of a system called CleanSeaNet. CleanSeaNet is a flagship system ruled by and operated by the European Maritime Safety Agency, EMSA, that you know very, very well. And they regularly analyze satellite imagery to detect oil spills at sea. So we were end users of this system, and we recurrently were deployed in order to verify what the satellite detected. At that time, the Spanish Coast Guard, SACEMAR, was also very, very active in remote sensing, and we organized workshops every year between all the maritime rescue coordination centers at the crews of the aerial units in order to discuss how we could improve our mission, whether it is oil spill monitoring or search and rescue, using remote sensing, which was advancing our operation very, very much. And we started to dream with the idea of having our own satellite remote sensing capacity at the Spanish Coast Guard, something that sounded very crazy at that time, but it turned out to be not so crazy. And there was also a consensus about what was needed from a decision maker and from a person that has to deploy an aerial asset or a ship, is that we had to put a lot of importance, a lot of relevance to high quality analytics, high quality information. So in order to go forward here, we, let's say, identify the basic steps that were the first one to identify, diagnose what are the final user needs, what a decision maker needs, and then to study the state of the art in satellite remote sensing. So this is the wish list that we collected, interviewing a lot of people internally in the Spanish Maritime Safety Agency, and was a list of 6 things that any end user needed to know when managing an event like this, a relevant, a significant oil spill. The first one is, did an oil spill occur? So let's say the state 0, is there an event? Is there something that I have to worry about? The second one is it really mineral oil? Is it not a false positive? Is it not a false alarm? Third one, where is the thick oil? As you know very, very well, the oil spreads a lot when spilled at sea. So it's crucial to understand where is the thick part of the oil that is actually compatible, that we can actually clean from the ocean. Also, a question that has legal dimensions as well is, and operational, of course, is what's the quantity of oil released at sea? And then another one, which is more familiar, maybe, where will the spill go and what is the source of the oil spill? So a basic description of how Earth observation works. So observing the Earth from the space using cameras in satellites, in a sense. So we have a satellite orbiting the Earth. The satellite produces a satellite image that is normally processed by the satellite operator. Then the image is received on the ground station and analyzed by an analyst, by a person who is specialized in the analysis of the satellite image. So then insights are produced that can be in form of a PDF report, which is the classic one, or it can be as digital information that we can see in a map, in a GIS, in a common operation picture, or any kind of geo platform. Some other foundational principles that I think would help to understand how this works, how the supply chain works. So normally we have 2 types of satellites, radar satellites and optical satellites that I will explain later on. The number of images that we can acquire over a certain area of interest depends on how fast the satellite is moving, and also on how many satellites we are using for monitoring a specific site. Then the timeliness in delivering the information depends on the operator of the satellite and also on the analysis. So normally delivering the image might take between 20 minutes to several hours, depending on how far is the ground station where I can actually downlink the data. And then the analysis takes around 20 minutes. This is more or less a standard of industry. It could be a little bit faster, or it can be a little bit slower, but it's around that. So what are the, let's say, basic advantages that we see in satellites? So the first one is that they see the big picture. They have a very big eye and they can monitor huge areas. As you can see here in the video, just with 2 satellites, we can scan the whole Earth in 5 days. And I mean the whole Earth. So this capacity for us is totally unprecedented. The second one is that, they don't rest. They are taking images all the time. And the third one is that they transcend all human boundaries. For us, it's the same to monitor the coast of Australia or the coast of New Zealand or the coast of Spain. We are just using satellites, receiving the images in our computer, analyzing them. So these are two examples. On the left-hand side, you have a radar satellite. On the right-hand side, you have an optical satellite. These two units, missions, are flagship missions operated by European Space Agency. And more interestingly, the data they produce are totally free. They're open source. So we don't have to pay for the images. So examples of how they see, right? On the left-hand side, you have a radar satellite. On the right-hand side, you have an optical satellite. So the optical resembles more of what a photograph is. They can, you know, they see in colors. And the interesting thing is that they see colors that we cannot see. So they see parts of the electromagnetic spectrum that the human eye cannot see. And especially this information is very, very relevant to characterize, for instance, oil spills at sea. On the left-hand side, you have what we call the standard of the industry, which is a radar satellite. And I will explain here how they work. So a radar satellite is an active sensor, meaning that they send a pulse, a radar signal to the surface of the ocean, and they read the intensity of the signal that comes back. So normally, if the sea is rough, what we would see in the image is a medium gray. And if there's an oil spill, it creates a mirror effect, and the signal of the radar goes far from the sensor. So we see the pixels with oil, we see them as dark gray or black. This is an example, a real example of the Baniyas event in Syria. This day, if I remember well, the oil spill was occupying a surface of around 1,000 square kilometers. And we can see this spill just with one image, you know, which is quite amazing in my opinion. How an optical satellite detects an oil spill is a bit different, but here they are what we call passive sensors. Here, the active sensor is the sun. So they operate similarly to a normal camera. So the light of the sun is reflected on the Earth, and we see what comes back to the sensor of the satellite. And especially for this application, we know quite well that the oil has a definite behavior. The oil reflects light in a very, very particular way, and that helps us to detect and characterize the oil at sea. So another example, this is a very recent event in the Gulf of Mexico. Unfortunately, after Hurricane Ida, some pipelines were broken, and they produced significant oil spillage close to the shoreline. So as I was explaining, this is, let's say, beyond the state of the art. We promoted some research with the University of Valencia with two groups, the Environmental Remote Sensing Group and the Image Processing Laboratory, in order to, let's say, go a bit forward, not only detect oil spills, but characterize them in thickness and quantity. So as I mentioned, the radar is let's say, the king, which is used by most of industry and most of companies. It's a very, very interesting tool, amazing tool, because it has all-weather and day and night capacity. We can see at night and through the clouds. And it has a very big eye. This satellite can cover the swath of the stripe that we can get with this satellite is around 250 kilometers. Just to compare this with the surveillance capacity of an aircraft, a typical patrol that we had in Spanish Coast Guard, that was around 4 hours. So the area that we were able to cover in 4 hours with the aircraft is covered by a satellite in around 30 seconds. So you can imagine, for maritime surveillance, we think there's no tool like this, especially when the areas are quite big. There are some constraints also, as in any technology, in the use of radar satellites. The first one is that a radar satellite tells us there is something here, but I'm not sure if it's an oil spill, because physically we cannot be 100% conclusive because of the physics behind the process. So there is some uncertainty, and there are some false alarms that have to be confirmed by other assets. Traditionally, the analysis of imagery has been human, which means time-consuming and expensive as well. And the information they can provide is there is something here, this is the position, and this is the area covered by oil. So after several years of research with the university and the Spanish Coast Guard, we decided to go forward with this initiative, and we launched Orbital EOS in order to provide services of advanced oil spill monitoring using satellites. So our approach, let's say, integrates what I already mentioned. We use any satellite that we can put our hands on, so SAR and optical, meaning more images, more surveillance capacity, and we can be more conclusive about what we are detecting. The analysis is based on artificial intelligence, so it's machines working for us, meaning faster, cheaper, more accurate information. Advanced analytics that were not possible before, I think, like providing thickness mapping or quantification. And we can also, of course, using AIS data, can identify the source if there's a clear link between a ship and a spill. So as a summary of the let's say, the sensors and the technology, the pros of using radars are we can see at night and through the clouds, we can penetrate clouds. The limitations is that radar satellites give us information about potential oil spills, the position, and the area covered by oil. In terms of optical sensing, the information we can have is identification of hydrocarbon. If the sun is illuminating the place in ideal circumstances, we can be 100% conclusive. We can derive also thickness of the spill, and we can quantify the oil released at sea. The constraints are that, of course, we need light, we need sunlight in order to be able to see, and we cannot penetrate clouds. So in certain places of Northern Europe or Antarctica, for instance, it's quite challenging to have information with optical satellites. So our approach, as I explained, is that combining different satellites, combining different sensing capacities, we must be able to answer most of the questions that were collected in the wish list, like did an oil spill occur? Are we sure it's mineral oil? What is the thick oil? What is the quantity? And what is the source using ancillary information and AIS data? So we had one missing, that was where will the spill go? So as you know quite well, for this, we use ocean modeling, so mathematical models that describe where the oil is going to be in the next hours or days. So we partnered with CMCC, which is an Italian foundation and has 30 years of expertise in forecasting oil spills at sea. And we're very, very happy to share that this capacity is already integrated in the tool. So the solution we have developed is called EOS Viewer, and basically we tried it to be, the perfect tool for us as users. So it's highly intuitive. It has been designed to be a one-stop shop for oil slick monitoring and reporting. You don't really have to be an expert in remote sensing or satellite, or even in oil spill response. It's very intuitive information that you can use, you can share, and you can even store in databases. It's based on the use of satellites, radar and multispectral or optical satellites. It can deliver advanced analytics using artificial intelligence. Again, we can identify the source if needed, and it integrates spill trajectory forecasting. So some use cases that we tend to see in the market and where we can help. So first one would be MARPOL enforcement. So the capacity to detect deliberate pollution at sea, something that we did in the Coast Guard very often. The second one would be proactive monitoring of assets. So the capacity to observe very often the environmental performance of my facility, whether it is a pipeline, an oil refinery, or an oil rig at sea. And of course, emergency response when there's a major event. So I think that if we share that images speak louder than words, then we say that satellite images speak even louder. So I have recorded some videos here that showcase how the tool works. So this would be a discharge produced by a ship in the Mediterranean Sea, and how a radar satellite sees the spill. We can characterize the spill in of course, the position and the area covered by oil. And we can produce a PDF report that is automatically produced in the platform in case you need to share this information with your colleagues, or if you need to have it in your archive. This is another example, MARPOL enforcement. Here we're using an optical image. Interestingly, we can actually see quite clearly the ship and the discharge in the wake of the ship. And if there are oil spill response experts here, that I'm sure there are, will agree with me that the likelihood of this being mineral oil is very high, because I mean, we can see the colors very well. Okay, the example that I shared with you, broken pipeline in the Gulf of Mexico. Unfortunately, this event lasted for a few days, and we could cover it for several stakeholders. And using an optical satellite, we were able to detect and characterize the spill. So for instance, where is the thick oil, which is here showed by the red polygons. So in case you need to, for instance, deploy booms or deploy a ship to take samples or use dispersants, we think this information is quite relevant for you to use. Interestingly, normally we monitor a place several days. So on 3rd of September, so the day before, sorry, the day after the last image, we could see the evolution of this spill, and we can, let's say, test if the measures that we have taken have been successful, and where is the oil in the present situation. This is another example of the oil spill in Syria this summer. This has been analyzed using synthetic aperture radar satellite. So we can know where's the oil spill. Again, we can produce a report that you can share with your colleagues within your department in case you need this information to be archived. And interestingly, we can here see how the oil is going to move in the next 48 hours. So we think it's what is interesting. First of all, it is integrated in the same place. So you don't have to use another software. You don't have to use another GIS. In case you want to run the forecasting, you can do it just pushing play. The second one is that the models run from the exact position and shape of the spill detected by satellite. So it's not a random cloud of points. It's the reality that has been extracted using analytics from the satellite image. We were providing this information daily for stakeholders in the Mediterranean Sea, and actually I'm quite glad to say that the forecasting was very successful. And this is the last example that I have. Here, another day in the Vanillas Syria accident. Using an optical satellite, as I shared, we can also detect where is the thick oil, let's say, concentrated, which is here showcased by the red polygons, and we can forecast the movement of the spill in the following days or hours, depending on the user needs. As you can see, the circulation in this part of the Mediterranean Sea is quite significant. So what happened is that the oil was captured by a giant gyre, and it was coming to Cyprus and Turkey, and then coming back to Syria again. So the Syria coastline was affected quite intensively. Just to finish, I think we have big hopes in the present and future, because space is a new paradigm. We have more launches every year, but you can see the numbers here of forecasting of satellite launches for 2027, around 900 launches in 2027, which is amazing. So that means more satellites than ever, more capacity to monitor, more images. That means also prices going down because there are more competitors. So the market is becoming more accessible to everyone. More frequency to monitor my asset or my exclusive economic zone. And using machine learning and artificial intelligence, we can derive information now very fast and very accurately. So this is it from my side. Thank you very much for this opportunity, and be glad to answer questions.
Great, thanks, Juan. Richard, do you want to unshare Juan, and then Richard can share and he can do his presentation on drones. But that was really illuminating. And I've got some questions we'll pick up at the end.
Right. Okie doke. Can you hear me okay?
Yeah, you sound great.
Good, good. Thank you very much. Well, thanks very much for inviting us to speak today. I'm gonna talk about drones and oil spill response. I should say we're a consultancy company, a drone consultancy company. We call ourselves a consultancy plus, which means effectively, you know, we consult with the intent of developing products and operational services that we then move on to operate. And the kind of the stage of the industry just now is that, you know, it's a kind of early part of the industry, and therefore that's a kind of an approach that kind of looks forward, and that's how we approach it. But we've been introduced today through NRC, who are one of our clients we're working with on something different, still offshore, but a different project, doing something with drones offshore. We're kind of helping them with drones in general, and looking for opportunities for them. And they are obviously the kind of oil spill experts, if you like. And so I'm not going to talk about oil spills and that kind of stuff. I couldn't claim to be an expert at it. It's more what drones are, what they can do, and how to kind of plan and use them. You know, the industry is young, and therefore, you know, everything is a little bit of an exploration just now. But effectively, as a company, we supply advisory services, and we also have links, non-exclusive links to a number of equipment partners, and I do a number of projects. We're based in the northeast of Scotland. The background of the company, I suppose the expertise of the directors is probably offshore, so oil and gas, renewables, that kind of stuff is where we're kind of focused mainly. But we have a broad network, and actually we've just started a business in Australia last year. So we'll take our learnings that we have in Scotland, and we'll transfer them to Australia. And in Australia, we will take the learnings there and transfer them into the UK. And you can see on the right-hand side, it kind of says, you know, some of this stuff is aligned. in terms of our knowledge and capabilities, but other things are a wee bit different. So things like mining, big thing in Australia, not such a big thing here, but lots of technologies that the drones are using down there that can be shared with us over here. So I suppose the opportunity and why we're talking about drones today is that I don't think is exclusive by any stretch of imagination, but drones offer a safer, greener, and more cost-effective alternative to status quo. Yeah, so that's a kind of sweeping statement. It's not always true, but if you think like an unmanned vehicle versus a manned vehicle, there's obviously safety benefits for using that. A smaller vehicle as opposed to a bigger vehicle, you know, if you put a person in a vehicle or a person going to do something, huge amounts of safety equipment, all that kind of stuff, that creates extra weight, and therefore you need to provide extra power for those vehicles. So a drone without someone in it doesn't have that, therefore should be greener. Also, generally, not exclusively, they use batteries. So depending upon which country you're charging your batteries in, that might make you greener than someone using like petroleum. And then more cost effective. So I always say cheaper, but I was told that's not a very good, it's not a very nice word to use. So but cost effective is not really just about being cheaper. It's about providing a better value solution. So being able to, there's a number of things that drones do that maybe aircraft don't do quite as well. So that give you a better outcome. And the key bit that why we're kind of interested in drones is that basically the environment, global environment for drones is moving from what is visual line of sight, so a drone being within 500 meters of the pilot, to moving beyond visual line of sight. So about 10 to 15 years ago, everyone went nuts for drones and everyone went out and bought them and all the companies invested and everything like that. And they all thought, great. What they'd forgotten about, they developed the technology, they spent billions of dollars, and then they forgot about the regulation. The regulation is air regulation, and it's been around for 100 years, yeah, and it doesn't move very quickly, and that's why aircraft are very safe. Yeah, so they kind of misjudged that a little bit, but now within the next sort of between now and say 2025, 2026, you know, the ability to fly beyond visual line of sight for deliveries and long range infrastructure inspection stuff, that's now the opportunity, and therefore it's a huge business opportunity and really one of the reasons we're involved. And as I said, the regulatory environment's the constraining thing. It's not really the technology. The technology is there. What we need to be able to do is scale it, develop procedures, all that kind of idea. And what it'll do is that there's very few industries that a drone can't add something to. Yeah, so not only will it enhance existing ones, but there's a whole lot of new industries that it will go into. And pretty much every buzzword you ever hear in any sort of government policy will align to what drones are. So AI, advanced manufacturing, software, everything else. You know, there's always some kind of link into drones. As I said, there's a kind of big opportunity out there. We aim to be early adopters. We work with a number of companies to kind of help them to create drone solutions that either improve what they have or build their offering. And the way in is one of the things we look at is looking for lower risk use cases. So anything over kind of rural areas or offshore has less people to either be who are nervous of the drones or worried about their the pictures taken, that kind of stuff. So that's kind of how we approach things. So we look for good use cases with our clients where we can add value and do it safely, trying to get ahead of the curve in terms of how the industry develops. So it's a big old industry. It's going to be a big old industry. You know, this revolution I talk about, moving from 500 meters and one pilot, moving to beyond 500 meters, so anywhere out to hundreds, thousands of kilometers, and multiple pilot or single with one pilot controlling multiple drones, increasing autonomy and swarms of drones. You know, these sort of things put together this is from the UK government, these numbers, but you know, that's $74 billion it's worth to the global economy, or the size of the drone industry to the global economy by 2035. And in the UK, it's 16 billion by the figure they've used by 2030. And the thing to think about drones is that although they're, well, depending on your perspective, although they're a kind of cool bit of technology, that on their own, a drone does limited amounts of stuff. There's very little that you can do with just a drone. Yeah, it's really just a platform. It's really, the drone comes into its own depending on you put on it. So you either attach a box onto it, and that allows you to deliver things, or you attach a sensor and a camera, and that allows you to collect data. Yeah. And the other thing is that you can maybe use it as kind of communications platforms and that kind of idea. And by removing, these safer, greener, cheaper, or cost effective, I should have written in there. You're removing the human error, from activities, which is one of the sort of greatest safety risks in many things. And it also kind of moves in terms of what we're doing with drones is very much about electrification of flights. If you've been watching this stuff, in the UK, you're obviously watching a number of places, but the UK released their energy policy recently. It's all about a big chunk of it is about electrification of flight to reduce the emissions from aviation. So drones are involved in all of that. But effectively, when you're thinking about drones in a project or whatever you're going to do, there's kind of there's a number of components, but effectively there's airspace, so where the drone is going to fly. There is the safety case for that drone flying, and then there is the operator with the physical drone. Yeah, so to fly in airspace, you need to get people to agree to do it. You need the stakeholder buy-in. You need to be able to see and avoid things. So just now, within 500 meters, that's the job of the pilot. Pilot with his own eyes can see the drone, and if he sees something in the way, can avoid it. Once you move beyond visual line of sight, obviously you need that technology that allows the drone to see that himself. So the machine deciding what it should do. And then you also need to tell people what you're going to do in that airspace. The operational safety case is all about the technical capabilities of the drones, the things it can do and the things it can't, and the things that may happen. So the levels of redundancy and all that kind of idea. And then how you are going to operate it. So what constraints are you going to put upon yourselves, and how are you going to make sure that you fly it safely? And then finally, there's the drone and the operator itself. So the drone needs to be maintained, and the pilot needs to be trained and licensed to fly that. And depending upon what drone you have, will affect the training and the licensing you have. Depending on what drone you have, will affect the maintenance and the level of rigor in terms of the how the regulator manages you. So here's a number of drone types. There are, I suppose, there's millions of different kinds of drones, but I've kind of broken them down into a number of. They're not quite, I suppose, maybe not quite characterized properly, but give you a good idea of the things there. So the first there, I've got a multicopter. So that's the ones that you would see you'd buy in anywhere from a toy shop into a kind of specialist drone shop. There's a picture of me there flying a little drone there. That's about a 1,300-pound drone. Most amazing piece of equipment. A company called DJI from China, who have about 65% of the consumer market around the world. They're the people who revolutionized the drone industry about 15 years ago. There's that little drone there. It's very stable. It can hover. It can fly about 70 kilometers an hour. Yeah, but it is limited. It has a battery life. It'll fly for about 20 to 30 minutes. And actually, you find that regardless of how you scale a multicopter up, with its battery powered, generally you'll find that it'll be 20 to 30 minutes is really its flight time. Then, if you look in the kind of middle, there's the one there that's just the VTOL drone. So a drone flying above the countryside. That's a VTOL, so vertical takeoff and landing, like a Harrier jump jet. And eVTOL to the side of it, which is effectively the same, but would be a people carrier. Those things, they take off straight up and down, so they need a landing pad, but they don't need a runway. They can hover for a period of time, but it depends upon how they're set up. So like a multicopter will be able to hover indefinitely as long as its battery lasts out, whereas a VTOL drone with its wings, it can fly further, but it probably operates. You don't want to run its batteries down. It uses its batteries to hover, so you have very limited hover time generally. So the drone has to keep flying, doing whatever task it's doing. But they have an extended range. They'll fly a lot further. A multicopter, you might get, I don't know, anywhere from sort of 8, 10 to 30 kilometers. You'll get a VTOL. VTOLs will be out to sort of 70, 80, 90. Some of them go out to hundreds of kilometers. Then in the bottom there, there's a kind of orange and white one. That's a fixed wing drone. It's like either like an aeroplane or a model aeroplane. They fly off runways. They have extended ranges. That one there is a 450 kilometers. That one will fly with an increased, and it has a kind of increased payload as well. The bigger they are, they'll be able to fly further. I then talk about tethered. There's a bit about tethered drones. So tethered drones will be a multi-copter of some sort, but one that's attached either to the ground or to a power unit or to something else. And being attached to a power unit, it means it can kind of stay where it is, not indefinitely, but not far off. And it also means because it's attached to the ground, it means that it's easier. It can't just kind of take off. It's tethered. Say that if it's a 100-meter tether, it can't go more than 100 meters away. So if it's 100 meters from danger, then it should be safer. And the example I use is that there was a hover bike, so a drone that a person was meant to ride on. They were doing a trial at it at one of the places in the UK. They built the drone in a test. They did it. Something went wrong. They pushed the kind of return to home button, so the kind of emergency stop button. It didn't work, and the drone went up to 5,000 feet. And at 5,000 feet, there's all sorts of aircraft up there. It's very, very dangerous. So tethered drones, they can't do that. So that makes them a little safer. And then finally, the other one I mentioned is in the top left is a drone in the box. That's probably a multi-copter drone of some variety. It goes in a box. The box will be remotely placed, and then with a kind of internet connection, and then you'll then control it from a distance away. So take off, land, go off and do a survey, or if you put it outside say like a sort of overseas, like a camp or something like that, you could patrol every hour. The drone could take off, patrol round, and come back and land. It'd be recharged in the box. There is a company that retools them in a box, like an ROV, a subsea ROV that would put different tools on where you can get the same with drones. Next thing is the airspace and safety case. So this is kind of air law. Air law is 100 years old. It's international law. It's stuff that's not that easy to change. So it's not that you can, as the UK, can't just say we're going to do this, that, and the next thing. And the other country can't. It goes into a much sort of bigger grouping, and that's one of the reasons everything takes more time to do. But effectively, you generally have different classes of airspace. Class G airspace is where most things are. That's basically anyone's allowed to go wherever they want. Yeah, and that's the freedom of the air is kind of one of the key rules of air law. And within drones generally, you fly them within 500 meters of the pilot and up to 400 feet. And although normal planes can come below 400 feet, they routinely would stay above 500 feet. And that's where the difference comes. You can't fly it again. You can fly drones above that. You have to go for special permissions for that. So if you want to fly beyond your 500 meters, what you generally have to do is you have to box it off. You have to box the airspace off. This has been done in the UK. It's been done for 50, 60 since the Second World War. Draw a box on a map, and no one's allowed in unless they speak to the people who are controlling that box. It's called a temporary danger area. But the problem with it is it contravenes the general rules of the air, which is kind of the air is free for everyone to go to. So it kind of annoys everyone. Not too bad 20, 30 years ago, because people who were doing them with the military. Now there's 251 temporary danger areas around the UK. An awful lot of them are to do with drones. So it's inconvenient for everyone. And then the operational safety cases. So you fly within the segregated airspace, but then you need to get your drone, the things you have to think about, things like the hazards in terms of your operational area that they're flying along in. So that's both people, where people would get hurt, but then also obstacles, things like power lines or whatever. The technical limitations of the drone and the things it can do. Whether you're flying kind of within visual line of sight, just beyond, maybe using an observer or additional person, or if you're flying truly beyond visual line of sight. And in the UK, true beyond visual line of sight, although you see it in a lot of places, people talking about it, it's very, very limited in the number of people who can actually do it currently. There's a very small pool that you can probably count on one hand. It's important to know the positioning of the drone. So the drone understanding where it is on an XYZ coordinate. And that looks at not just GPS, but all sorts of other positioning mechanisms, both on the drone and potentially on the ground, to allow you to triangulate where it is, and then also being able to communicate both you with the drone and the drone ideally back to you. And in rural locations, in a city that is 5G enabled, no problem. In a rural area, that communication can be really difficult. If you're offshore, you often go into SATCOM. When you're in SATCOM, that costs a lot of money. So depending on what you're doing, then that puts a restriction on you. You then also, drone swarms are multiple drones. So just now it's very difficult to do. The drone light shows you see at Christmas and things, that's an example of drone swarms in a very restricted area. Yeah, so those can be done but flying multiple drones to multiple places is actually a pretty difficult thing to do just now, and it's only just on the beginnings just now. And then it moves more and more into autonomy. So not just the drone flying itself, and seeing other airplanes and things, but then actually deciding what to do. But the goal is to move away from segregated airspace and to move to unsegregated, where there's general aviation, there's manned aviation, and with unmanned aviation operating together. Now, the key thing there is that the technology, the technology kind of exists, but it's not certified. Yeah, it's not. Current airspace or air use is very, very safe. There's not much safer than going on holiday in an airplane. Yeah, but what they're trying to do is now you've got this new technology that has to be as safe. Yeah, safer than a car, as safe as an airplane is really what they're looking for. And the regulator won't allow widespread flight of drones until that's reached. So the cost benefit of it. So I think one of the key things, especially when we're talking about oil spill response and kind of mapping and all that kind of stuff, is the repeatability of the flight plan. So it knows what it is. The drone knows what it is, X, Y, Z. You put a program in, and it can return to the same point on the same speed, on the same time after time after time. So if you have an oil spill on day one, you can map it on day one, you can map it on day two, you can map it on day three and day four, and you can overlay those layers, yeah, and you can see where it's progressing. There's then a question of person v software. When I speak to people, there's always really, it's easy to say, yes, we'll put artificial intelligence in this, build some software and whatever, but quite often the person has to be involved in there. We've not, the software and artificial intelligence, whatever, aren't quite there in terms of people. So you've got to be careful in terms of, selecting the correct technology, that it's actually as good as a person just now. I'm sure all these things come on, but just now, that's definitely, the drone is only doing a job of collecting the data. If the data is not as good as your person, then it's not it doesn't tick all the boxes. The key, I suppose, the key challenge with drones, pretty much in everything that you do, is duration versus weight. The heavier the drone is, or the heavier you make the drone, the less distance it flies. Yeah, so if you put a big package in it, it flies less than it would otherwise. If you put one camera on it, it will fly further than you'll put 3 cameras on it. Yeah, and if you need, if you need to put 3 cameras on it, you need a bigger drone. Eventually, you have a bigger drone, or it's either too difficult to get permission to fly, or actually it's maybe just as cheap to use an airplane and more cameras in it. So that's always the challenge, is the weight, duration to weight when you're thinking about it. The safety, the great safety benefit of them is that it's unmanned. Yeah, it uses, it's flying, you're kind of removing human error from it as well, I suppose, with the software. Environmental considerations are things, you're using batteries, not using either batteries or reduced volumes of aviation fuel, and the noise. You always have to think about that, especially when there's people around. Offshore, it's not such an issue, but whenever you're flying them onshore, that's one of the key things that, in terms of air law and approvals and things, noises, you don't want drones flying near your house or you getting in the way. It's those kind of things we have to avoid. And financially, you should have a reduced cost per flight, because generally a drone will be cheaper than a plane. Doesn't probably involve so many people, probably doesn't involve so much maintenance, probably doesn't involve this, that, and next. So per flight, it should be cheaper, but it depends what you're doing on the flights. But then not just making it cheaper, but maybe the benefit is that you can actually put multiple platforms out for the same cost, if you like, gathering the same amount of data, or the replication, or any of those things in quality I've got above. So what I thought here is, I just thought I'd run through quickly for sort of 5 minutes or something, was the kind of planning considerations. So again, I said I'm not a oil spill expert. We were in NRC the other day, and we kind of I took a couple of slides in, and we kind of knocked some of these around. So this isn't a definitive list, but kind of the things I would think about as a drone consultant, a drone planner, when going through. And I've chosen 3 examples. They may or may not be the best examples, I'm not sure, but I think they're relevant in terms of oil spills. So again, they're talking about, you know, like how are you going to get there? How far have you got to fly to go and do whatever job you're going to do? So that's the duration versus weight conundrum. You know, different kinds of drones that we've gone through. You know, some go further than others, some stay up longer than others. Yeah, they get different fuel types. You know, if you have a battery drone tends not to go as far as an aviation fuel drone, but an aviation fuel drone will still be greener, if you like, than a larger aircraft. And then a number of drones, yeah. So are you, if you need to do it one operator and many drones, that's quite a complicated thing to do. But obviously remember, if you're in a country that has, or location that has, what you need to do is just gather reasonably basic data, you could maybe have local pilots who come at a reduced cost and have lots of local pilots doing lots of little things within 500 meters. So those are some of the things, working out how you can get numbers of drones if that's what's required. The environmental conditions, the weather is important, particularly the wind. The wind's the kind of main thing really for drones. A lot of them will fly. I mean, some of them won't fly in rain and that kind of stuff, but generally it's the wind that will be the thing that will stop you before anything else. Flying at day and night, there are different considerations for both of them. Obviously, and especially in terms of visual line of sight, you can't see very far at night. So, these might be limitations. The noise constraints, if you're flying near people, that's or built up areas, like that's a real thing to watch out. And then wildlife, things are nervous of them. Generally, in the UK, you're kind of wondering out for dog walkers, but the key one's birds. So birds don't like drones, so you have to be careful that you know what they are and you've got actions on and things. And then airspace, depending what you're going to do and which one of those three scenarios you're in, there's a speed of permission. Yeah, so if you want to just do it tomorrow, you can come and ask me, and I can go and fly my drone tomorrow. Yeah, and I can fly within 500 meters, pretty quick. I can do it. In fact, I get a whole lot of friends, and we can fly loads of drones together within 500 meters. But if you want me to fly 400 miles offshore and do X, Y, and Z in the UK, that will take some period of time to go through, and it's a period of months, not a couple of weeks. The height that you need to fly at. So I was saying, obviously, you're flying generally to 400 feet, but if you need to go higher, then again, that's possible. Depending which country you're in, it might be easier to do it kind of off the bat. But often, as soon as you go beyond above 400 feet, you will need special permissions to go and do that. Again, that takes time. And then your communications, like how you're communicating with the drone and the drone's communicating with you. That's a key thing, because obviously, should something go wrong, you need to be able to intervene. And then also what you have on the ground. So that's the ground, that's the drone port, or whatever you want to call it, where the drone lands and takes off, how its batteries are charged, or where its fuel is, and all that kind of stuff. So you've got to think about them as well if you want to have enduring operations. So the first one here I took was the Braer of Shetland. Like what would I be thinking of here? Well, it's collecting data. Yeah, potentially you could do sampling. There are a number of drones now that would, depending on the sea state, would fly out and you could actually lower them down towards the sea, not necessarily onto it, and they'd be able to sample what's in the sea, the components that may be useful. Something like a multicopter, that's off the north coast of Shetland. There's loads of people with drones there. Yeah, it's very close to the beach. It's probably more than 500 meters out, I suppose, the end of the vessel. But you could have drones with very, very good cameras, multiple pilots, yeah, all they're sort of 400 pounds a day out there flying around gathering all your information. If that was what you wanted, especially wanted to do it fast. At multicopters, they'd be hovering, they can sit where they are, and gather data over longer times. You can then also live stream the information back, depending upon the comms that you have available. And then if you took that and you had a tethered drone, then you could actually place the tethered drone there, and it would kind of sit there indefinitely until the incident was over, and all that information can then be put back to the operations room. In the UK, tethered drones, you have to have an operational safety case for that. It has to go to the CA. So unless you have one already, you find someone with a tethered drone, you can't just go and do it tomorrow. Other countries, so I know like in the Netherlands and in Poland, that's not the case. Yeah, a tethered drone is something that it's not considered within airspace because it's tethered. So you can do that tomorrow if you have one. I was told just to kind of mention that obviously when this happened, the winds were very high. Yeah, they were greater than 30 miles an hour, and so your drone your multicopter wouldn't fly in this situation probably anyway. So you would have alternatives of maybe a fixed wing or a helicopter drone, but again, there are bigger safety cases, need to find the people to do it. There's not so many of those folk around. And then here, in the just off the picture, is actually Sunbury Airport as well. They have their own airspace, which is a useful thing depending how far it extends. Because if it's firstly, you have to deconflict. The airport rather will own the airspace, so they can tell you what can go on within it. So if you speak to the airport, they would allow you to go and do X, Y, and Z with a drone in this situation. And obviously, this is a kind of major disaster. So if I take an example of the mountain rescue in the UK, they have drones, and they are allowed, should there be a kind of life and death situation, those people, although they're not qualified and they don't have the capability to fly further, they have dispensation to phone the emergency, the air traffic services, and the air traffic services quickly box off an area where they're going to fly their drones. So they have a way that very, very quickly they can start using drones. In a situation like this, there would be an ability to go and do that. So drones, you wouldn't have to, you can maybe put a bigger and better drone up than you were planning to do otherwise. So the second example I've got here is Macondo in the Gulf of Mexico, obviously like a couple of 100 kilometers offshore. Again, data collection, live feedback, improved visuals, because you can put the drone up higher. There was a bit about if we were sampling in this, before you put the you sample the water before you put the dispersant down, and you could sample it regularly after you put the dispersant in, and you could see the differences over time in terms of the effects of the dispersants. Potentially, you could be doing something to do with logistics. You could be moving things around between the vessels, and potentially even from the shore to the vessels, depending upon the distance and the drones that you have. There was a suggestion from NRC that maybe one of the things you do is the ignition of the oil when you're burning it off, and that would just effectively the drone could fly over with whatever it is that ignites it, and it could be released and do that. And then by using drones to begin with, you could use you could use drones flying off the back of the boats that would then actually identify where larger aviation sorties were going to go. So they were kind of targeted rather than flying everywhere. Yeah. And then the third one was onshore. Well, kind of I took the example of Nigeria. Whether that's fair or not, I'm not sure. But effectively here you could fly coastline surveys. You could do long range coastline surveys, identify oil flows, potentially then put in smaller drones to go and do that. So that's when you identify somewhere, there's go down to the beach and without getting a boat, fly the drone, see where everything was going, and then make your decisions. Separately, if you have people out in the boats, it might be useful if the drone was to fly off the boat. At least it gives you a perspective of, say, 120 meters in the air rather than you looking at it from the water level. Potentially, you can attach loudspeakers on the drones. They're used for crowd control in a number of places. But equally, they could be used as bird scarers, to keep the birds out the way of any oil spill. You can use it as a communications tool to rebroadcast your signals if you're in a rural area. Yeah, and in the future, something like personal transport, you could these things are autonomous, so the rescue workers could be taken to here, or multiple rescue workers could be taken to different locations autonomously and brought back. Yeah, and I suppose just one of the points I've got on the bottom there is that like a lot of these multicopters, the little ones, like I was saying, I mean, the one I was showing you there was £1,300. There's really good ones, £600 by a company called Parrot. These things are pretty much, especially in terms of an oil spill, these things are pretty much consumables. These are highly capable, they're ultra HD cameras, that kind of idea, but you could actually buy a job lot of them. And if you lose them or they break or you do some sort of kamikaze maneuver to ignite some sort of fire, it's not the end of the world. It's not something that it's not thousands and thousands and thousands of pounds of equipment, so there's opportunities, especially in emergency cases for this. And I think this is my final slide. Effectively, this is a kind of pitch, I suppose, or just some information on what we're doing. So there's all these kind of ideas and things out there, and obviously drones are used to some extent in oil spill response. But one of the projects we're doing is we're based North East Scotland, halfway between Dundee and Aberdeen. We're building Scotland's first drone port with the local council, and our aim is to kind of open up the North Sea, the central North Sea, with the new wind farms and the oil and gas platforms and the marine vessels. Then open that up to drone operations. So all the stuff I've talked about, all the surveys, all the logistics, all that kind of stuff, and we're doing that as a project with the council, and it aims to build a kind of trials area, and we'll build a number of drone ports that we'll deploy, and then be able to move around. So put one in Montrose and then move it to Brecon, yeah, demonstrate, and that would demonstrate a kind of modular deployable concept. So although we're moving it around Angus, where there might not be a huge oil spill coming anytime soon, you know, there's no reason why that drone port couldn't be boxed up and flown somewhere in 48 hours to then deal with an oil spill, wherever it was. And it includes not just the drone port, but we're working out how the airspace could be, a template of that airspace could be put down. So in the example of somewhere like in the Gulf of Mexico, some kind of oil spill just off the coast, you could take our modular system and a number of ISO containers, it would go up, it would land in the Gulf, or next to the Gulf of Mexico, you'd unpack it, and within 48 hours, you'd have a drone operation ongoing. So that's kind of what we're looking at. We have a project running March till May next year that anyone's welcome to come along and see the drones flying. And then a kind of follow-on project where we go from what was temporary danger areas into this unsegregated airspace. And we're applying for a UK government grant just now to do that. And one of the use cases we'll put in will be oil spill response. So some kind of like, we'll have drones flying over the sea doing some a sort of trial, if you like, as to how we would do oil spill response. So that's kind of what we're doing as a bit of a pitch at the end there. But that's the kind of summary about us, and obviously I'm very grateful to Oil Spill Response and for NRC to invite us along. So thank you very much.
Thanks very much, Richard. That's grand. That was really, really interesting. In terms of questions, if anyone has any questions, stick them in the chat. If you can unshare, Richard, can I just ask a couple of questions? You mentioned weather. The radar satellite image is okay in all weather types. Mm-hmm. Do you think the technology will change so you can optimize the radar images to get better visibility of what's on the water through the clouds, or are we at the limit of it?
Well, that's a very interesting question, Mark. Well, there are some groups working on this, especially in the US. If I'm not wrong, NOAA is promoting some very, very interesting research about how we can derive, for instance, thickness of the spill using radar. And I think if they succeed here, it would be very, very interesting to see how it works. Definitely, I think it's relevant for the oil spill response community. Beyond that, I think automation is the next step. So rather than having people analyzing imagery, to have full automation of the radar images. Traditionally, false alarms has been a huge problem for everybody.
Okay, and the other, obviously, we're changing for marine spills. The nature of the fuel that is being used is changing, and has that affected the effectiveness of the imagery? Because in Europe now, we're using very low sulfur fuel oil, so it perhaps doesn't have the reflective capability because it is being more absorbed in the water column. So whilst the same quantity is there, is it as visible as traditional marine fuels?
That's a very good question, Mark. I don't have a clear answer for this because we cannot go that far using optical satellites. So what we can do is to discriminate what is mineral oil, what is hydrocarbon, and what is not, but to identify the type of oil that is beyond the state of the art with these kind of satellites. There's a new generation of satellites that they're called hyperspectral, and they give a footprint really of how the oil reflects light. With that satellite, we would be able to classify this is IFO 380 or this is low sulfur fuel.
Because that is where I believe it's sort of they're trying to move it so that it uses, very in simplistic terms, a form of spectrometry to identify what it's seeing, and it is all through interpretation linked to some artificial intelligence, which is open source, so that by pooling all the data you get better definition out of the analysis that you can do through the computer program, but using a form of spectrometer. Yeah. Okay.
Yeah, absolutely. That's I mean, you described it as it is.
Yeah.
The challenge that, I mean, the theory is there, the technology is there. The only problem that we have is that, you know, launching a satellite, it costs several hundred millions. So the European Space Agency has a hyperspectral mission that is going to be launched in 2029, if I'm not wrong. This data is going to be open source with 30-meter resolution, which is quite good.
Yeah.
So sometimes we have the technology, we have the methodology, we have the analytics, but we don't have the satellite, we don't have the data.
Yeah.
That's the challenge.
But isn't but actually the computer technology we've got is doing amazing things with relatively low technology, and so it's getting the two to work together, and that's why you need funding, and you need projects, and you need data, and you need real incidents to learn how the new technology copes with the real world.
Yeah, absolutely. But I mean, I don't think why putting an hyperspectral sensor in a drone wouldn't work. It would work. The only problem, I mean, to classify the type of oil, it would be very, very effective. The only problem is that normally these sensors are quite expensive and quite specialized. But if there's any company that can achieve this, I mean, we can discriminate very, very effectively what kind of oil it is, really. Yeah.
There's just for information, you can apply them onto drones. In agriculture, they put them on drones. There's 2 companies in Scotland that have got one. So I presume there's loads in Spain as well.
Just on another point, one of the other issues which is gaining presence within our industry is marine debris and plastic pollution. Now, satellite images can just see what they can see, but are you getting tasked to look at this sort of issue?
Is this question for me or for Richard?
Yeah, for you, Johannes.
Okay. Yeah. It's a big challenge. It's a big challenge because we should, let's say, first of all, agree on the basic assumptions, right? So there is plastic at the ocean. We could agree on this. There is a concentration of plastic in the ocean that could be observed from space. That's a very long way forward. So we have limitations of spatial resolution, the level of detail that we can see. If instead of using spatial resolution, we use spectrometry, as you mentioned, so we use how the plastic reflects light. Actually, it's quite similar to the hydrocarbon because it's a derivative product. But again, we don't have the satellites to achieve this in orbit yet. So I think there are great hopes that this can be done in the future, but it's going to be in a few years, I think.
Yeah. Okay. But it is interesting, isn't it? It's are you and this is a question for you as much, Richard, are you seeing more engagement between in response organizations, be they police, military, air, sea rescue, in using aerial surveillance to try to help them to extend their line of vision?
Yeah, I mean, I think especially of what I know, the emergency services are very much into it. So the police searching, we've got in our project we're doing next year, we're going to do a serial with the police. So they generally, they have the way that it works. Obviously, if there's someone missing, they go out and look, and literally 2 policemen arrive at ground level and start hunting around. But very quickly you end up with 8, 10, 15, 20 policemen there. And that takes everyone out of doing every other job. So they're very much into it. So I think most of them are.
Good. I think that's great. I've one comment which Paul Harold, who works for Public Health England, has dropped a note in, which is worth looking at in chat about how some projects are you looking at satellites and remote sensing, including drones, looking at flood and hazmat detection. And that's an interesting link to follow. And so that's great. I haven't got any more questions. I've asked the two my brain cell could possibly think through and remember, but I'd really like to thank both of our presenters, one from Orbital EOS and Richard from DTLX Drone Solutions. They were really interesting and contemporary presentations, and thank you both for the case studies, but also for pointing out advantages, disadvantages, so we get a balanced impression of how these techniques can be integrated into response plans, but also in preventative work. So I'm really grateful for the presentations and the clarity of them. So that was great. I'd like to thank you, Mark Shepherd from NRC, because he was sort of one of the catalysts behind doing this. So thank you, Mark. I know you're there somewhere. I'd like to thank OAMPS, who've enabled this to happen, our OAMPS Hazardous Industries. And of course, thank you very much indeed for attending. Now, what I will do, this webinar is recorded. I'll have the joyous task tomorrow of trying to make sure that it cuts out all of my junk, and we end up with a package which we can stick on our website on Friday, and we will share the link to you and to all who've registered. And within a day or so, on Friday, it should end up as a link on our website. So thank you very much indeed for attending. I haven't shared my screen, so you don't know what I'm looking at. So I'll just do that. The next webinar, our next webinar is going to be on the 17th of November. And this is being this is in a sense partnered with RSK Raw. It's on drill rig selection and safety. We all use drill rigs when we're doing ground investigations. So they are critical, but they can also be dangerous. And it is so often that you get to doing a drilling job and you really haven't got the right one. So this is some guidance on selection. So that's our next one. Please register for that if you want to attend it. And on the 24th of November, just a week later, we'll be doing spill response to biofuels. Biofuels are changing how spill response is going to be done in the future. The UK and Ireland Spill Association with Oracle Environmental have done some work on it, and our accreditation arm, International Spill Accreditation Scheme, have produced a technical guidance document, which is based upon that research on how to handle response to biofuels, which is changing. So that's good. So I'd like to thanks very much. Thanks again to our speakers. Thanks for joining us, and we will catch up with you. We will catch up with you at the next webinar. So have a good evening, and thank you very much. Bye-bye.
Thank you very much, Mark.
Thanks very much. Bye.
Thank you. Bye.
Bye.